Quick review about yesterday. We started a new chapter, chapter 5 of the reference textbook, about rational expressions and rational equations or rational functions. And a review here is the definition of rational expression. Look what we have here on these lines. If you have a polynomial as the numerator and another polynomial as a denominator, you will have a rational expression. It is because it's a ratio, right? It's a fraction or a ratio of two polynomials. And usually you're going to find variables. If we're talking about rational expressions, you're going to find variables. But even if you have, let's say, 5 over 2, this is a fraction, right? You are used to this kind of thing. You might say this is a rational expression as well. If you think as the numerator as a monomial with only the constant term, and you can think about the denominator as another monomial with just the constant term, and then you might think this as a rational expression as well. But usually, when you're talking about rational expressions, you're going to think about something that have variables on the denominator, on the numerator, or on both. It involves some kind of expressions with variables or polynomials. And yesterday we also learned how to find the domain of rational functions. Remember this? To find the domain, let's say you have this function here, h of x equals x squared minus 21 over x squared minus 36. Just forget about the numerator, look only at the denominator. To find the domain, you must first find the values of x that makes the denominator equals to 0. On this case here, let's say x squared minus 36, we will have two values of x that makes this 0. X equals 6 and x equals negative 6. After you find those values, you're going to say, well, the domain is going to be all the real numbers except negative 6 and 6, because we don't want to have the denominator as 0. This causes a problem because we don't have a solution if the denominator is 0. Okay? The domain is going to be all real numbers except, you're going to remove, you're going to delete, you're going to expel from the domain all the numbers that makes the denominator equals to 0. And questions so far? If you have any questions, we started slowly with simple questions yesterday on the quiz to evaluate functions, rational functions, to find some the domains or the numbers that you have to exclude from the domain with some rational expressions. Remember yesterday? So today, if you don't have any questions or comments or any feedback that you want to send me, let's move to today's topic. Today we will work on simplifying rational expressions. Sometimes you are kind of scared or annoyed, or you don't like to work with fractions, right? I know that sometimes a few students, they complain they hate fractions, they don't like fractions. And one of the reasons is because of that. To be able to work with fractions and work with rational expressions as well, we need to know a few tricks. And one of the main tricks is this: how to simplify fractions or how to simplify rational expressions. Because sometimes the thing is looks very complicated, but if you know how to simplify, you're going to be able to transform something hard, difficult, complicated into something else equivalent but very easy and straightforward. Look here, and the concept is simple. Fundamental principle of rational expressions. Look at this. If you have P, Q, and R as polynomials, let's say we have this rational expression here, P times R over Q times R. You can rewrite this as P over Q times R over R, and this is how you simplify, because R over R is equals to 1. And then you can write as P over Q times 1. This is P over Q. And this looks much simpler than that, right? This is the concept. This is why we are able to simplify rational expressions, because we can find common factors on the numerator and the denominator, which are divided by each other. They are equals to 1, so we can simplify. Instead of doing all this step by step, what we do is, if we have P times R over Q times R, this is, we just simplify it like this. This is equals to P over Q, and that's it. The concept, look at that, the concept is kind of easy. But then when we try to apply it to an example, it's not as clear as this one on the definition, right? Let's check here this next example. Let's say if we have this rational expression here to simplify. And the rational expression is 2x cubed plus 12x squared plus 16x over 6x plus 24. Don't need to be scared right now. This is one of the hardest, it looks like one of the hardest questions on the quiz. The quiz is much simpler. If you understand how to work this, you will be able to work the hardest question of the quiz. So check this out. We will first factor the numerator and denominator. We're not going to do this. This is just, we done yesterday, is to find the domain. And then after you factor out, you're going to be able to simplify the expression. So factor out first the numerator. Find a number that you can factor out from all the terms. The greatest common factor. If you check the coefficients, one greatest common factor is going to be 2, right? 2 is common to all the terms on the numerator. And another, if you look at the variables, you have x cubed, x squared, and x. So you bring to the, you're going to factor out the one with the lowest exponent. So just x. X is common to all the terms. Now we can rewrite this as 2x times x squared plus 6x plus 8. Right? And here on the bottom, you can factor out 6 times x plus 4. Agree? Now you have to remember something from last chapter, chapter 4. We will have this polynomial that we still can factor it out using the AC method. Remember AC method? AC, 1 times 8 equals 8, and B equals 6. We need to find two numbers that multiplied is equals to 8, and the sum is equals to 6. And 8 is going to be 1 times 8, or 2 times 4. 2 times 4. And that's it, right? Those are the two possible combinations. definitely is going to be 2 and 4, right? 2 plus 4, 6, 2 times 4, 8. So we can break this down as 2x plus 4x. Check this out. Repeat. I'm right here in the bottom. Repeat 2x. Repeat 6x plus 4. And let's break down this polynomial here. X squared plus 4x plus 2x plus 8. Right? And finally, we can factor this out using grouping. Factoring by grouping. Remember this? And let's repeat again 2x. So 2x. And here on the bottom 6x plus 4. And factoring by grouping, we will have the first one, we can factor out x times x plus 4. Right? And the second one, we can factor out 2x plus 4. If you have the same binomial, we can also factor it out, and it's going to be repeat 2x, we're not working on 8 yet, 6x plus 4. And we can write this as x plus 2 times x plus 4. Nice! Because we will have x plus 4 on the bottom, on the denominator, and x plus 4 on the top, here on the numerator. That means we can simplify. See? This is something we can simplify. The answer is going to be, well, first check if you can simplify the coefficients. 2 and 6. We can divide 2 by 2 and 6 by 2. So 1 over 3, right? The variable x, there's nothing on the bottom that we can simplify, so keep x. And x plus 2, there's nothing at the bottom that we can simplify with x plus 2, just keep x plus 2. And that's the answer. That's the right answer. Write the answer the simplest way. You don't need this one in front of it. And 3 here in the middle. This is going to be our answer. Much simpler, much nicer to work than the original polynomial. The original polynomial is this one. See, the original rational expression. It's a huge polynomial over another binomial, and now we have something much simpler, much nicer. It looks like easier to work. Okay, do you have any questions about this? And again, this is the harder question of the quiz. It will look like that. Do you think this is too complicated? A little bit? Not so much? Kind of? What's your feedback? Sometimes I'm kind of focused, concentrated, and working on the question, and I think it's clear in my mind. But maybe for you it doesn't look that easy or that clear. A bit hard, right? Thank you, Jacob. Yeah, this is going to be the harder one, the most difficult one that you're going to find on the quiz. I suggest you practice on the quiz. We start with less difficult ones. The first A, B, and C are not so hard, and then the level of difficulty will increase slowly, gradually. This is one of the hardest ones. So don't be scared. We can work together. We can practice on a few questions together if you need. And maybe the last one, the last question of the quiz will look just a little bit like this. Okay? If you have any questions, tell me now. And a specific question about the step, about anything that I did here you didn't agree, or you didn't understand 100%, or you're still puzzled by any of these steps. If you don't have a specific question, maybe we can practice, and you can also ask questions during the quiz. Agree? Can we work on the quiz then? And practice. Before moving on, I need you all to answer this challenge to me, and this has everything to do with the simplification of rational expressions or fractions. Look at this. What is going to be the answer? You have 9 fractions multiplied together, and this looks like it's going to be a huge number over another huge number. Can you simplify it? Send me a message now with your answers. And this is how you're going to do. You're going to simplify most of the numbers on the numerator with most of the numbers on the denominator, and you're going to find the answer 1 over 10. 1 over 10 is going to be the right answer for this bell work. Now let's move to the quiz. Yeah. Thank you, Jacob. You will. And thank you, everybody. Kion, Makina, Cynthia, Kalia, and Madi. Thank you for your answers. Let's move on and work on the quiz now. Check, and here we have the quiz. Check the first one, the first question, letter A. Let's start very slowly with very simple questions. We have 100 times x cubed times y exponent 5 over 36 times x times y exponent 8. What are you going to have to do to simplify? It looks like right. It looks like right. Yes. Yes. Check the coefficients first, the numbers. We can divide 100 by the same number that you can divide the 36. I think you can divide both by 4. So you can simplify here. Dividing both by 4, we have 25, and here at the bottom we have 9. 25 over 9. Okay, so this equals 25 over 9. Now check the variables. We have x cubed on the numerator and x on the denominator. Keep the one on that have the highest exponents. So we're going to keep the one on the numerator that have the highest exponents. And subtract the exponents. 3 minus 1, here is 1, right? 3 minus 1. So you have the exponents of the result, x squared. Now let's check y. Y exponent 8, and the denominator is higher than y exponent 5 on the numerator. So we keep the one on the denominator, and you're going to subtract the exponents. 8 minus 5, 3. And that's it. This is how I find the answer. This is the answer for letter A. Now let's work on a few more questions. And Give me 1 minute, I'm going to check attendance, and then we can work together on as many questions as you need. We might be able to factor out 6 on the numerator, so 6 times a plus 3. And on the denominator, we probably can factor out 9. I think 9. Check this. 9 times a plus 3. Cool. Now we have a plus 3 on the denominator and on the numerator that we can simplify. The answer is equals 6 over 9. But 6 over 9 we also can simplify. You can divide by 3, both numerator and denominator. 6 divided by 3, 2. 9 divided by 3, 3. That is the simplest answer, the simplest fraction, or the final answer for letter G. Thank you, Dainara. So letter G is here. Do you need H or K? Or C, or maybe D? Does anyone need help with any of those questions? C, D, H, or K? Let us see. We have, first check the numbers. We have 7 and 14. And I think we can divide both. 7 by 7 is 1, 14 by 7 is 2. So we have 1 over 2. Now we have on the denominator W 11, and on the numerator, on the denominator W3. The one of the highest exponents is on the numerator, so we keep it on the numerator and we subtract 11 minus 3. 11 minus 3 is 8. Okay? Now letter Z, variable Z. We have on the numerator exponent 6, on the denominator exponent 3. The highest one, the highest degree, is on the numerator, so we keep it on the numerator. 6 minus 3, 3. The answer, well, if we simplify, we don't need this one. The answer is going to be W8 times Z cubed over 2. Let me see. Thank you, Joelian.